All right, so we are in 6.5 and we are now solving absolute value equations. Uh, Just to kind of a quick review of what absolute value is. Absolute value is a number that determines the distance from 0. So the absolute value will always be a positive number. So the the absolute value of 5 equals 5, but the absolute value of negative 5 equals 5. Because if you look at, this is a terrible line graph, but so say I have negative 5 here, I have 0, and I have 5. And so if we go to the definition of absolute value, the distance from 0, so the distance from here would be 5 units. Also, the distance here would be 5 units. So that's how they come up with absolute value um, definition. So if we were to go into examples of solving absolute value equations, we have A, where we have the absolute value of x equals 7. So what we need to do is we need to find what x will equal 7. Well, obviously, x can equal 7 because the absolute value of 7 is 7. But also, if we remember from our little example here, we see well we have negative 5, absolute value of negative 5 equals 5. Well, also, x can also equal a negative 7 because the absolute value of negative 7 is also 7. So you have to keep in mind that it can be both, the inside of the absolute value can be a negative or a positive number. So when you are solving absolute value equations that are a little more complex, you have to remember the negative portion of that solution. Kind of like in B. Now B, it says the absolute value of negative 3, or no, absolute value of x minus negative 3 equals 8. Okay. So what we're trying to find is what in here, the inside of our absolute value, we have to make it equal 8. But we remember that the inside of our absolute value can be both positive and negative. So basically what you have to do is you have to write two separate equations. On the inside, you have to write x minus 3 equals 8, because we know that the absolute value of 8 equals 8. And also we have to write x minus 3 equals negative 8. Oh, I'm sorry, shoot. Let me erase that. That is wrong. I don't know why I wrote 11. Sorry about that. Okay, so we have to remember that x minus 3 also equals a negative 8. Because if we remember from what we had up top, we know that here the positive 5 equals 5 and the negative 5 equals 5 when it comes to absolute value. So solving for x, I'm going to add 3 to both sides, which gives me x equals 11. Here I'm going to add 3 to both sides. It gives me x equals a negative 5. And those two answers will hold true. Because if you plug either 11 or negative 5 into x and solve for it, you should get the absolute value of 8, because 11 minus 3 equals 8. Absolute value of 8 is 8. You got negative 5 minus 3, that is a negative 8, and the absolute value of negative 8 is also equal 8. So those two answers hold true. So now let me get some more room to work with. When you see you have values that are outside the absolute value parameters. First off, very similar to solving for a variable, you want to get the absolute value terms all by themselves on one side of the equal sign. So to do that, first I'm going to add 5 to both sides, which then leaves me with 3 times the absolute value of 2x minus 7 equals 9. Then I'm going to divide by 3. So now I have the absolute value of 2x minus 7 equals 3. So now I've completed step 1 in that process. I've got the absolute value by itself on one side of the equal sign. So now I'm looking for the absolute value of 2x minus 7 equals 3. So we need to take what we learned from example B, and we have to rewrite this into 2 separate equations, where 2x minus 7 equals 3, and 2x minus 7 equals a negative 3. So I'm going to add 7 to both sides on this one, which gives me 2x equals 10, and then x equals 5. Again, I'm going to add 7 to both sides here, so then I got 2x equals a positive 4, and x equals 2. So, 2 answers. X equals 5, and x equals 2. If we were to plug that back into the original equation, say I would have x equals 5. Well, if I were to put 5 in here, 2 times 5 is 10. 10 minus 7 is 3. So the absolute value of 3 is 3. So 3 times 3 is 9. 9 minus 5 equals 4. Checks out. Now let's remove that 5 and add a 2 in there. So 2 times 2 is 4. 4 minus 7 is a negative 3. But the absolute value of negative 3 is a positive 3. So 3 times 3 is 9. Minus 5 is 4. So x equals 5 and x equals 2 checks out. Second portion of this lesson talks about the absolute deviation. And what that means is if you have another term, another term for it is called the absolute error, because if you have a number x from a given value, the absolute value of the difference of x and a given number will give you the absolute deviation. So the equation is the absolute deviation equals the absolute value of x minus the given value. A lot of times you see this. The example I used in class was tire pressure in a car, where they give you the value, which is like 34 psi or something like that, plus or minus 3. So so that means it can be no higher than 37 psi and no lower than 31. That's kind of what the parameters were. But for this, they want you to find the values that satisfy the absolute deviation. So if the given value is 5 and the absolute deviation is 8, what we have to do now is just plug them into the formula. So 8 is our absolute deviation, so it'll be 8 equals the absolute value of x minus our given value, which is 5. So now we have to remember to use what we learned from the previous examples, is since we have the absolute value by itself on one side of the equal sign, we can now separate this into 2 equations, where 8 equals x minus 5, and where negative 8 equals x minus 5. So I'm going to add 5 to this, 5 to that. And so 13 equals x. Add 5 here, add 5 here. and this would be -3 equals x. So that's the values for x. It could be 13 or it could be -3. Last example is we have the given value is -9.1 and the absolute deviation is 1.6. So plug it into the formula. So I have 1.6 equals the absolute value of x minus a -9.1. But I have negative, so that's going to be plus plus. So it would be 1.6 equals x. 1.6 equals the absolute value of x plus 9.1. So now that I have this here, I can, or I have the absolute values on one side of the equal sign by itself, I can now write this into two separate equations where I have 1.6 equals x plus 9.1, and also I have -1.6 equals x plus 9.1. So if I were to subtract 9.1 to both sides, I would get, here I'd have a -7.5 would equal x. Here I'm going to subtract 9.1 to both sides, and 9, so that's what? -10.7 will also equal x. So there you have it. That is solving absolute value equations and also being able to use absolute deviation to solve given values. And hope this helps. Until next time.